Hello folks, and welcome once again to my channel on my geography teacher. I am your facilitator Elisha Champondako, a graduate from the University of Education Winneba with a Bachelor of Arts degree in Geography and Political Science. Today we are going to talk about the Earth's endogenic and exogenic forces that causes changes within the Earth. And in the course of the discussion, if you have any question, kindly leave it under the comment section of this video. Also, you can send a WhatsApp chat to the number 0556 970 568 and I will definitely respond to your questions. So let's move on to the objectives for today. At the end of the lesson, what are you expected to be able to accomplish? You should be able to explain the forces that causes movement within the earth crust, define folding, explain the types of folding, and then you should be able to discuss landforms that are associated with folding. Now, what comes to mind is that the earth continues to undergo several changes because of the movements that are found both within and on the earth's surface. So the earth is constantly undergoing what changes due to movement within the earth crust. So whilst we are seated right now, wherever you are, there are some movements that are occurring. If it is raining at your area, there is some form of what changes that is occurring within the landscape that we have there on the surface. So day in, day out, these changes that is occurring on the earth's surface, within the earth's surface, is as a result of what movement that occurs within and on the earth's surface as well. Now, these movements within the earth may be massive in nature, and once it is massive in nature, it causes crustal rocks to be displaced, and this is what we call diastrophism. Any activities that results to massive movement of the earth crust, leading to rock displacement. So whilst we are seated, there happens to be some movement within the earth crust. Plates begin to move away from each other, and anytime that these massive movements occurs, there happens to be changes within the earth surface. And so on the surface, the rocks may be subjected to degradation or aggradation. Remember, when I started, I said that the movements or the changes are not only brought about as a result of movement within the earth crust, but also surface processes as well. And these surface processes that brings about changes within the earth is what we call degradation, any activity that tends up to lower the earth surface, and aggradation, any activity that tends to give rise or raise the earth surface, is what we call aggradation. So these two activities, degradation, aggradation, also tends to change the earth surface. Now, within the earth, there are forces that causes movement within the earth crust, and these forces are tectonic movement. This is the mother of all movement within the earth crust. It is the primary movement of all activities that occurs within the earth crust, and these tectonic activities is just talking about the up and down movement of crustal rocks along fault line. A fault is just a crack. So you can see that sometimes when you are looking at your building, there happens to be a crack on your building, or on the earth surface there are mostly crack. That crack there is what we call a fault. So the up and down movement of crustal rocks along faults, which result to upthrows and downthrows, is what we call the tectonic movement. We also have another force that we call compressional force, and compressional force just deals with the lateral or horizontal movement of crustal blocks towards each other. So here the blocks are moving towards each other. So we have this crustal rock and then this crustal rock, and then these crustal rocks are being brought to each other, and this is the force of compression. Now, under the tectonic movement, let's look at the arrows here. You can see that this one moves upward, up through, and then this one moves downward, which is the down through. And so these are the two movements. Let's move on to the other movement. We can talk about the tensional force. The tensional force, which also deals with the lateral or horizontal movement of crustal rocks from a central block in opposite direction as a result of and this normally results to faulting. So you can see that here we have the crustal rock here, one here, and then the other also here. And so instead of they being brought together or against each other, this time they move away from each other, and this becomes the tensional force. Now, anytime that tensional force occurs, it mostly results in what? Faulting. Now, the two main movements, the tensional and compressional force, what you need to understand is that tensional forces mostly result to faulting, whilst compressional force mostly result to what? Folding. But not forgetting, compressional force can also lead to faulting. Are we okay with that? Good. Now, the last one that we'll talk about is volcanicity. Now, students mostly underchange volcanicity for volcano. What we need to understand is that volcanicity is a process. Volcanicity is a process, but volcano is a landform. So volcanicity is just the movement of molten rocks or magma vertically or horizontally within the earth crust, whilst volcano is a landform, a mountain on or a hill through which molten materials erupt or through which magma hot erupts. So volcanicity is a process, volcano is a landform. Very good. So now we've been able to identify the forces that causes movement within the earth crust. So there is a note here that says rocks usually fault when they are under hot tension and fold when they are under compression. So it means faulting is mostly associated with tensional force, whilst folding is mostly associated with compressional force. One thing you need to also remember is that tension or tensional force does not result to what? Folding. Okay, so now let's look at the images that we have here. At any point in time, any of you have done this before. In the case of this, somebody doing what? Crumpling a sheet of paper, somebody folding a shirt, and then here somebody folding rice. So let's look at this particular one where we have the red circle. You can see that it's a common thing that when you come to the African home, you see people seated and then the fold in your hand. So it's a typical way, one of the ways that food is being taken in our part. Now, all these things are associated with one form of force, which is compression. Anytime that you fold the paper, you are compressing the paper. Anytime that you are folding your shirt, it is a form of compressional force. Anytime that you have something in your hand and then you are squeezing it, it's a form of what? Compression. And so this brings the whole idea to what? Folding. What is folding? What do we mean by folding? Here we are not going to talk about situations where we are going to crumple a paper, but now we are going to talk about the situation where the earth itself is being bent or crumpled. So folding is defined as the process of wrinkling or bending or what? Crumpling of rock strata as a result of compressive force, otherwise compressional force acting on crustal block. So you can see that here the main force that causes folding is the compressional force. Now, why does folding occur in sedimentary rocks than igneous rock? This question mostly comes out. Students normally begin to ask the question that why is that most times or more often than not folding is associated with sedimentary rocks than igneous rock. Yes, why? Let's try to think about this. Why do you think folding occurs mostly in sedimentary rock than igneous rock? A few seconds more. Very good. So the reason why folding occurs mostly or often in sedimentary rocks than igneous rock is that sedimentary rocks are hot, soft, and they are having bedding plane. And so because of its soft nature, it's easy for it to be what? Crumpled than igneous rock. You see that igneous rock are very hard, and so it becomes difficult for it to be compressed, for it to form any folded structure. But sedimentary rocks, because of the bedding planes, because of it being formed in layers and then its soft nature, it is able to be crumpled to form these folded structures that we have. And folding results in high mountain ranges that we normally call the fold mountain, and they mostly form the continuous chain. So most highlands that we have here are as a result of what? Folded structures. So when you look at this mountain, Mount Everest, found on the Himalayan is a typical folded structure, and it's a very long and extensive mountain range. So folded structures are mostly of highlands, and folded structure always and consistently they are being compressed, and since the forces are still acting on it, they continue to give rise to new heights. So several years to come is either Mount Everest will have its height increasing as a result of continuous compression of this mountain, or its height decreasing as a result of denudational activity, which is weathering and then erosion. Are we okay with that? Okay, so typical example is the Mount Everest found in the Himalayan. And so let's look at the structure of a fold. Folded structures often occurs in series. It means they don't occur like once, but rather they are in series. So we have one here, the second one here, the third one here, and it continues in that manner. And they have anticlines and synclines. The upland is what we call the anticline, and then the downland or the trough here is what we call the syncline. So the upland is called the anticline, and this side is called the syncline. Then the sides here, and then this side is called the limb, where you can walk on mostly when you go to the villages, and then people normally farm on the folded structure. Where they normally climb, that side is what we call the limb. Are we okay with that? Very good. We also have a line of weakness where the folding occurs, and that line of weakness where the folding occurs is what we call the axial plane. So in this case it can be here, and one thing you need to understand is that the axial plane does not always assume the same position. It may be vertical, it may be lateral, or it may be horizontal, depending on the force acting on the rock layer. Now we have deep valleys, and the deep valleys, that is what we call the trough. So in the syncline is where we have the trough. So this side is called the trough. We have the axis. We have the axis, which is the axial plane, where we have the line of weakness. We have the limb, which is the side. We have the anticline, which is the upfold, and then the downfold, which we call the syncline. Are we okay with that? Very good. Now let's look at the types of folding. Let's look at the diagram here. We have several types of folding. We have the symmetrical fold, we have the asymmetrical fold, we have the overfold, we have the recumbent fold, and we have the nape or overthrust fold. The symmetrical fold, the asymmetrical fold, the overfold, and then the recumbent fold. So let's look at what each of the fold, the structure of each of the type means. Let's talk about simple fold or symmetrical fold. The simple fold is just a type of fold where the limbs dip in the same direction, or the same angle in the opposite direction, the same angle in the opposite direction of the axial plane. Now in this case, the axial plane is always at a very vertical position. The limbs are of equal angle, they are of equal size because of equal compressional force acting on the rock. So in this case, let's look at the diagram that we have here. This is the axial plane, and then these are the limbs. You can see that the limbs are having the same angle, and then the limbs are even of the same size, and this gives the definition of a simple fold. However, there are instances where a force at one end may be greater than the other end. Anytime that the force at one end is greater than the force at the other end, it results to the other types of folding that we are going to talk about. And so the second type of folding that we'll be talking about is the asymmetrical fold, which talks about situations where two limbs dip in opposite direction, but one limb is steeper and shorter than the other because of what? Unilateral pressure on one side. So it means in this case, the pressure that is coming from one side is far greater than the other side. The arrows are interchanged. However, in this case here, the pressure coming from this side is stronger than the pressure coming from this side. As a result of that, the axial plane is what? tilted to the left. So let's look at how the axial plane is tilted. You see that the axial plane is tilted to the left. It tells you that the pressure coming from this side is stronger than the pressure coming from the right hand side. So the pressure from the left is stronger than the pressure from the right, leading to what? The one limb falling, or one limb being steeper. So this is the steep limb, the steeper limb, and then this is what? The steeper and shorter limb, and then this is the longer and then gentle limb. And that is for the asymmetrical fold. Now, anytime that there is a strong pressure exerted on the asymmetrical fold, this is what happens. The anticline will then tend to be lying over the syncline as a result of greater compressional force. And both of the limb dip in the same direction. So let's look at it. You can see that this is one limb here, the other limb here. Now they are both dipped in the same direction. So here this one goes to the left, this one is also tilted to the left, and this is about the overfold. It is lying almost on top of the other, and this is what we call the overfold. And a typical example that we can cite is the Akwapim Togo Atakra range, which you have in Ghana, and then it stretches all the way to Togo Atakra. Then the next fold is the recumbent fold. When an overfold undergoes a great earth movement, we have what we call the recumbent fold. And for the recumbent fold, the limb is lying nearly horizontal as a result of an equal compressional force. So let's look at the diagram here. In a situation where this overfold is subjected to intense compressional force coming from the left side, this fold will almost lie horizontal. So in this case, it will assume this position. Have you seen it? So there is a force. This force here coming from the left was greater. And let's look at how the axial plane has been tilted. It is almost lying horizontal, right? Very good. And then you can see that here, the fold, the pressure coming from here, or the force coming from here, is greater than the one coming from here. So now the fold, the upper part of the fold, is lying almost on the other side as the block that is found beneath. And so you will see that with the recumbent fold, the fold is lying almost horizontal to the bedding plane of the other rock. Then we look at the overthrust fold. When recumbent fold undergoes intense pressure, there is something that occurs. Because of continuous pressure exerted on the recumbent fold, a fault may develop on the fold. A fault may develop on the fold. And once the fault is developed on the fold, it will cause the recumbent fold to break. Now when it breaks, continuous pressure on the fold will push. So thrust means it will push it, it will shift it. So it will push the block away from each other. And so the upper limb will lie over that of the lower limb. And this is what we have here. So initially it was a recumbent fold. But because of continuous pressure exerted on the upper block here, it caused a crack to form over here. And once the crack was formed here, the force had not ceased. It is still in existence. So it will end up pushing the upper block over the lower block. And so it's shifted to the right side. Here it's shifted to the left side. So this is the arrow indicating that there was a crack here. In this case, the upper block was almost lying on top of the lower block, but the force that was coming was greater at the left than was greater at the right than the left. So it pushed it over after the fault was created, and that is the recumbent fold, the overthrust fold. Now we have minor folds that we call the anticlinorium fold, and then we have the synclinorium fold. The anticlinorium folds are just talking about extensive series of anticlines and synclines that are found within an anticline. So when we have an anticline, then we have several series of anticlines and synclines found within an anticline, then we call it an anticlinorium. Then the synclinorium, we are talking about what? Yes, give a guess. Very good. Series of anticlines and synclines found within what? A syncline is what we call synclinorium. So typical example of an anticlinorium is the Lamberg Mountain in South Africa, and then that of the Swartberg Mountain also in South Africa. Now let's move on to the formation of a fold mountain. Fold mountains are chains of huge complex mountains, and they have these characteristics. They are made up of old rocks with steep sides. Because of issues of sedimentation, these rocks are made up of generally old rocks, because older rocks, igneous rocks, and then the other ones who undergo denudation, will undergo weathering, and then be transported to one area. Remember, these rocks still has the characteristics or properties from where they came from, and so these rocks are mostly made up of old rocks, and then they have wrinkling appearance because of compressional force. They always have this wrinkling appearance where we have the anticline and syncline coming in, and then they exist in layers. Why do they exist in layers? Because they are coming from sedimentary rock, and one characteristic of a sedimentary rock is that they exist in what? Layers, or they are bedding plane. Very good. Then we have anticlines and synclines in them, which we have already established, and they form the most widespread mountain range in the world with the greatest of height. Typical example that we cited earlier was what? Very good, Mount Everest, found on the Himalayan. They also mostly occur along coastal areas as a result of what? Geosyncline, because of the geosynclines that we have. Geosynclines are just talking about depression within which sediments are accumulated, and so because of the presence of geosynclines, they are mostly found within coastal range. Now let's look at the mode of formation of the fold mountain. Each of the diagram here will be used to explain something, so let's kindly take note of that. Now, they are formed through a concept that we call the geosyncline concept. The geosyncline concept. Deep within the earth crust. So here you kindly bear with me, pay attention so that we get the understanding. Deep within the earth crust, there is a fluid sitting deep within the earth crust, which we all call what? Magma. Very good. Now this magma produces a current that we call the compressional current. The compressional current tries to escape or move away from the magma, and whilst it moves away, it ends up coming to meet the earth crust. So this is the earth crust. Okay, this is the earth crust. So it moves, the compressional current moves here. It is not the magma but the convectional current. The convectional current moves away from the magma and gets to the earth crust, but once it gets here, there are no cracks here for it to escape, and so it pushes the earth crust upward. It pushes the earth crust what? Upward. Now once it pushes it upward, it will result to the sagging of the earth crust, so it will sink in. The earth crust will sink in when the compressional force, the convectional current retreats. So here the earth was flat in this way, then the convectional current pushed the earth's surface to assume this shape, a near arc shape. Now when the convectional force begins to retreat, it will sag the land. It will begin to push the land inside to form a depression that we call, or a subsiding basin that we call a geosyncline. So one, there is a crustal or the earth crust here. Conventional current is moving out from the magma, but when it gets to the earth surface, there is no crack for it to escape onto the earth surface, and so it pushes the earth surface upward. Are we okay with that? Now when the conventional current is receding, it then causes the earth surface to sag in, so it will form a depression, and then that depression is what we call the geosyncline. Now after the geosyncline has been formed, erosion or denudational activity will bring materials from the foreland into the geosyncline. So we have the foreland here. These are the foreland. One here, the other one here. Now materials will be washed from the foreland into the geosyncline. Compaction will begin to take place. So sedimentation and then compaction or cementation will begin to take place. And then continuous accumulation of sediment within the geosyncline will cause this geosyncline to form what we call sedimentary rocks. Are we okay with that? Now, these sedimentary rocks begin to accumulate, compress, and then gain another weight. Now, when they gain another weight, they begin to cause the geosyncline to sink in the more. And once the geosynclines begin to sink in the more, it pushes the foreland towards each other to form a crumpling within the geosyncline that we call fold mountain. And so the thick layers of sediment accumulate and get compressed by its own weight, and then this causes the geosyncline to be pushed downwards. And once the geosyncline are pushed downwards, compressional force now begins to act on it and then causes the formation of young fold mountains that we have. And so it all begins with a geosyncline, the concept that we call a geosyncline concept. Convectional current will try to move away from the magma, and then as it moves away, it forces the earth's surface to assume an arc-like shape. And once the convectional current recedes, it causes the sagging of the earth, leading to the formation of a basin that we call a geosyncline. The geosyncline begins to accumulate sediment from the forelands, become compressed, and then gain weight. Now, when it gains weight, it begins to sink in, or it is pushed downwards. And when it is being pushed downwards, so let's look at either side. Because it gains weight here, it begins to push downward, and now the forelands will be brought against each other, resulting into the crumpling of these sediments. And remember, it is not a day thing. It doesn't happen overnight. It takes several years for the sediment to even accumulate to form to accumulate and then cement to form new landform within the geosyncline itself. And then it takes several years for compressional force to force these four lands to move towards each other to form a land that we call a fold mountain. Now, the last aspect that we'll be talking about is the importance, significance, or influence of fold mountain. Let's discuss the importance of mountain. What are some of the importance of mountain? Yes, very good. So the importance of mountain has always been the same throughout, right? It serves as what? Site for tourist attraction. Very good. What else? Source of water. Very good. And a whole lot of importance that we can get from it. Very good. And so our discussion today focused on folding. We've been able to look at what folding is, the forces that causes movement within the earth crust, the types of folding, and the formation landforms that are associated with what? Folding. And so thank you for your time. This brings us to the end of our lesson on folding. I am your facilitator, Elisha Echampon Dako, and welcome once again to my geography teacher. Bye.